Hey everyone, so let's solve this LeetCode medium problem. Maximize number of subsequences in a string. So the problem states that we are given two strings, text and pattern. The pattern has a length 2. Now both of the strings consist of only lowercase English letters. Now we can either add pattern of 0 or pattern of 1 anywhere in this text string that we are given. Means we can add these characters, either of these characters anywhere in this string text, and exactly once we can add it. Okay, and we are also given that this character can be added even at the beginning or the end of the text. That means we can add in any positions in this text string here. Now we need to return the maximum number of times this pattern can occur as a subsequence of the modified text. Okay, so we need to find the maximum number of times this pattern can be found as a subsequence in the given modified, means given string text after we have modified it after doing some insertions. Okay, and I hope the definition of a subsequence is clear. So for example, if we have given a string ABC, then subsequences are of the form like AB, then AC, then BC, then ABC alone. Like, these are the subsequences. Okay, so any combination of like string is a subsequence. So now the text and like pattern can go, text length is can go up to 25 and pattern has a length of 2 exactly. Means only we can add these two characters. So let's see this input. Suppose we are given the text as this and pattern is AC. So let's try to first find out the number of occurrences of this AC in the original text only. Then we'll try to do some insertions in such a manner that the original count that we had is increased by a maximum factor. So let's try to see, like, if AC is the pattern, so we see this AC we have one and this AC we have another. So two subsequences we have as AC. So the original like count of AC in this text is 2. Okay. Now we can insert A in this text string or we can add C in this text. So like how will be like adding this text? So since we need to find this entire string AC, so if we want to add this particular character in this text and we want to maximize the number of occurrences of this as a subsequence in this, so obviously we'll try to add this A in as left as possible in the text string, right? And we want to add this text in the substring, since we'll need to add it in as far right as possible. Why? Because suppose we add A at the far start, so the new string will become A, and then we had the same A, B, D, C, D, B, C. So since we have added it at the start, we'll see like all the C's which would have occurred, means all these characters which would have occurred in this original string will be increasing the count by that number. Okay, so since here C occurred 2 times, hence the original count will be increased by 2. And hence the output that we will be getting, means the number of occurrences of AC in this will be now 4. And similarly, if we try to insert this C at the end, that means if this was the original string A, B, D, C, D, B, C, and if we add this C at the end, then all the A's that would have occurred before would be like having this C as part of the subsequence, right? So since only one way A was there, so this will be a valid way of it, right? Since we'll be able to maximize the, so in this case, count will be increasing by +1. So we'll see both the possibilities of either adding this character or this character. So, and we can adding the first character, the optimal way of adding it would be at the start, and the optimal way of adding this second character would be at the end, so that we can see like if we have added this second character at the end, then all the first character occurrences in this string can constitute for as a subsequence. And similarly, if we have added this first character at the start, then all the occurrences of the second character in this original string will be accounting as a new subsequence. Okay, so in this case we'll be adding this A at the start and we'll be able to get the overall count as 4, which is the optimal output here. Okay, similarly in this case, let's try to find the original count first. So original count will be AB, AB, and then AB, AB. So original count that we have is equals to 4. Now let's try to add this A. So obviously we'll be adding this A at the start to maximize the number of occurrences of AB. So we'll add A, then we have A, B, B. So for this A, again we see like we have got 2 new subsequences because the number of occurrences of B in this entire string was 2. So in this case we are getting +2. And similarly, if we try to add this B at the end, means second character at the end, so in this case we see Like the number of occurrences of the first character in the original string was 2. So in this case also we'll be getting plus 2 subsequences. This AB and this AB. Okay. So hence in the both the cases we are getting an increment of plus 2. So hence overall the maximum will be 4 plus 2 equals to 6. So this will be like the optimal count here. So what is the algorithm that we need to follow? First step is to find the original count. Original count means occurrences of pattern in text as a subsequence. Okay. Once we have find out, now we'll do two means. Insert pattern of 0 at start. So in this case, how much by how much value the means the number of subsequences will be increasing? It will be increasing by number of occurrences of pattern 1 in text, right? Because since we have added this pattern of 0 at the start, hence the number of means subsequences by which the number of occurrences will be increasing by the count of frequency of pattern of 1 in the original text. And similarly, if we insert pattern of 1 at end, that means the number of occurrences of pattern of 0 in text. So if we find out the number of occurrences of pattern of 0 in original text, then by that amount the number of subsequences will be increasing. So if we denote this value as like suppose value 1 and this is as value 2, so what do we need to find? The final result will be simply the OG count that we have calculated, plus will be, since we can insert only one character, so it will be like maximum of these two values. Okay, so we'll be inserting in such a manner that the original count means overall value is maximized. So this will be the final result that will be returning. Now, so we know like we'll be able to simply find the number of occurrences of pattern 1 as well as pattern 0 simply by iterating through the string only. Now we need to find out how we'll be finding this OG count, the number of occurrences of pattern in text as a subsequence. So since we know like this pattern is only of length 2, right? Only of length 2. So hence if we like try to fix this character, okay, so as we traverse in the text string, okay, now if we try to suppose this is equals to the pattern of 1, okay, that means if we fix this index and try to find the number of subsequences which end at this particular I, so it will be what? It will be the number of occurrences of pattern of 0 so far. So now what we need to find, number of subsequences ending at I equals to pattern. So if you want to find this, it will be simply what? Number of occurrences of pattern 0 so far. Because if we simply find the number of occurrences of pattern 0 in this part, then since if this value is equals to pattern 1, then that means the overall subsequences count will be increasing by this value, the number of occurrences of pattern. For example, in this case, if we see this given input AB, DC, CDB, AB, DC, DBC. So in this case, we want to find the number of occurrences of AC. So you'll see the places ending with C. So here we have C. So you'll find out in the left how many occurrences of A are there. So if you see only one A is there, so hence there is only one subsequence which is ending at this particular C. And similarly for this C as well, we only have a single A on the left, hence there will be only one subsequence which is ending at C. So hence we'll be taking the sum of all subsequences ending at this particular means pattern of 1, and then we'll be able to calculate this OG count. Okay, and while we are traversing, we can simply maintain this count as well of like the number of occurrences of pattern 0 as well as pattern 1, and then we'll simply like return the result as OG count plus maximum of these two values. So I hope the entire logic as well as like how we'll be implementing it is clear. Let's see the code as well for this approach. This is the simple code that we have. We have seen to find the OG count as well as occurrence 0 means denotes the occurrence of pattern of 0 and occurrence 1 denotes the occurrence of pattern 1. Now we iterate through the string. Now if ch is equals to pattern 1, that means this is equals to the I that we have is equals to pattern 1, means we'll be able to find a subsequence ending at this place. So we simply need to find the number of occurrences of pattern 0 so far. So it will be number of occurrences of pattern 0 is simply stored in occurrence of 0. So we'll store it occurrence 0 and we'll be increasing our occurrence 1 of count by 1 because the current character is pattern 1. So we need to find these two values, so that so that in the end we'll be means updating our overall result with OG count plus max of these two occurrences. And if ch is equals to pattern 0, then we'll update it with this value. And why we have not used else if here? Because suppose the pattern is simply RR. So in this case, if we use else if, then only one of the statements will be get executed, right? So then means one of the values will not get incremented, and in that case, we'll be getting wrong answer. Okay, so that's why we have used like separate if statement here. I hope you means if you try to do else if, then you will see the mistake that we will be making. Now in the end, we'll see like the two ways: either insert pattern of 0 at start or insert pattern of 1 at end. Hence, in this case, if we insert pattern of 0 at start, then the number of subsequences will be increasing by occurrence 1. And if we insert pattern of 1 at end, then the number of subsequences will be increasing by occurrence 0. So hence, we'll find the result by maximum of these two values and simply return the result. So as you can see, like the overall complexity of this approach is simply order of n, and we have not used any space, so space is constant here. And n can go up to 1e5, so this is of the order of 1e5, which will run like very fast in less than 1 second. So let's also submit this code here and see how much time it takes to run. This is the same code that we discussed. We simply analyze the two conditions, and yeah, it runs in 3ms, which is pretty fast. So this was a like a small observation based question, and like we are able to solve it just on the basis of like whether we means first making an observation like inserting where will increase our number of subsequences count by the most amount. And we saw like either we'll be inserting the first character at the start or the last character at the end, and then we saw like that will be the most optimal, and then the implementation was pretty easy for this problem. So yeah, I hope like you were able to follow along with the approach discussed here. And if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.